Okay, what are the important things that we need to know for the final exam from the chemistry unit? Well, most of them aren't things you need to know, they're things you need to be able to do. Okay, chemistry was very skill based. So, what are some of the skills? Naming compounds and writing formulas for compounds. Okay, which of course requires you to understand the difference between an ionic and molecular compound as well. Okay, remember that an ionic compound is a metal and a nonmetal. Okay, and a molecular compound is two nonmetals. Will I put compounds on the exam that could have polyatomic ions in them? Yep. Okay, so make sure you know how to use the table of complex ions or polyatomic ions, and Roman numerals. Okay, I would say that in the multiple choice, there's probably going to be a few naming questions / formula questions that would involve, chemicals that have either a Roman numeral or a polyatomic ion or something or both. Okay, so expect that you're going to have to demonstrate your ability to do that. It is also crucial that you can do these two things for the written response section where I go into reactions, specifically writing, predicting, and balancing. Right? Because if I write the question out in words, give you the names of the formulas in words, you're going to have to be able to convert those names into formulas so that you can write the chemical equation properly. Austin, question? You do not simplify molecular compounds. The prefixes tell you the numbers. You do simplify ionic compounds because they're a ratio. Yeah. No, you don't have to because, again, the prefixes tell you what the numbers are. Okay, this is big. Okay, it was big on your unit exam and it's big on the final. Okay, because a reaction question allows me to assess basically everything except the mole equation from this unit. Okay, it allows me to assess your ability to read, write, naming compounds. Okay, understand reaction types, write reactions, balance reactions, predict reactions. Okay, a reaction question is a great way for me to shorten the test by assessing a lot of things in one question. Okay, and I'm all about doing that on a final exam. Okay, I don't want to have to ask one question about every single thing when I can ask one question that covers 5 things. I wouldn't spend very much time going over the people, no. Okay, I don't remember putting anything trivia like on the exam. If I did, it was somebody like super important, like Rutherford or Dalton. They were kind of the really important guys. But yeah, I don't even remember putting them on there. Except maybe if I asked about the atomic theory, right? We would probably need to know the atomic theory for a multiple choice question or something like that, right? So what do you want to do when you're studying for chemistry? Peruse your notes, okay? Don't intently, repeatedly read them. You don't need to, okay? Go over them, look at things that maybe you highlighted, and that's really about it. The stuff that's mostly on the final exam about chemistry is about you demonstrating your skills, because that's what Mr. Real cares about when you get to Chem 20, okay? He doesn't really care whether you remember what Dalton said, okay, or what Rutherford said, or whether you remember about Rutherford's gold foil experiment or anything like that. He cares whether when you get there, you can write chemical formulas and balance and predict chemical equations so that he can teach you more interesting things. Okay, so make sure that that's what you can demonstrate to me, because that's what I got to be able to tell him when I put in your final mark. Okay, because when he looks at who's on his Chem 20 list and he sees, oh, this person didn't do very well in chemistry, he's probably not going to be impressed. Okay, so we got to make sure that we know those things. Always, yes. So if I ask you to predict it, it'll usually say in the question, predict and balance. Yeah, but if you're predicting a reaction, you never write a reaction that isn't balanced, right? So yeah, if you're writing out reactions, and I'm going to ask you to do that, I'll give you reactions in words, just like what are on your worksheets in the chemical reactions assignment that we did. That would be a good one to go over, by the way. That's exactly what they'll look like. Okay, here's a word, or here are the reactants in words. Predict and balance. Okay, and then obviously the mole equation would be the other big skill thing. Okay, so N equals little m over big M, and of course Avogadro's number. I'll give you that on the test. It's not something you need to memorize. Okay, it's on the formula sheet on the back of the periodic table. I think I put 2 of those on there, if I recall. Okay, so there's 2 mole equation calculations on the final exam. And there's 4 chemical reaction predictive products balance in the written response as well. Okay, so definitely those are things that you're going to want to do, because each one of those reaction questions is out of 4. Each one of the mole equation ones is between 4 and 5. I don't remember off the top of my head. It's around 50 multiple choice, and I think 12 or 13 written, somewhere in that area. Right? It's out of over 100 marks. Okay, it is almost exactly 1.5 times as long as a unit exam, because you have exactly 1.5 times longer to write it. Okay, everybody with me there? If you're done my final exam in an hour, you didn't pass. Okay, I'm just putting that out there because it's never happened. Not that it couldn't ever happen. I did have one kid who took that as a challenge and almost pulled it off. He did very well, but it took him 1 hour and 6 minutes. So it doesn't count. He wasn't done in under an hour. Okay, but he was just one of those like brilliant. He should become like a brain surgeon or work for NASA or something. But yeah, if you're done it in an hour, you missed some stuff. You're not finishing my science final in an hour. Okay, I would expect that for most people, it's going to take you between 1.5 hours and 1 hour and 45 minutes for you to finish. Okay, and that gives you some time to take a little break, decompress, and then kind of go over a few things. Okay, just know that when the 2 hours is up, though, the test is over. Okay, like you can't keep writing. I can't give you any time after the 2 hours. Okay, you have to stop writing after 2 hours. Yeah, so watch the clocks. You face the clocks in the gym anyway, so you should be able to, and you got your watch and whatever. Not your phone though, because you're not bringing that with you. We've been clear about that, right? Okay. All right. Other little things for chemistry. Like these would be the major things, like study these for sure repeatedly, do a whole bunch of these. Okay. Then smaller things, okay, that could be in the multiple choice, you know, in maybe let's say 2 to 4 questions in the multiple choice would be things like the properties of compounds. Okay, because we did a lab on that, but it's hard to have a written response item about that. So there are some multiple choice questions that ask, you know, things like, you have a compound, an unknown compound in front of you with these properties. Its likely identity is A, B, C, or D. So if I said it was a green crystalline solid that was highly soluble and highly conductive, has a pH of like 6, the options would be like carbon dioxide, water, nickel 2 chloride, ammonium nitrate. Okay, like it would be nickel then, right? Because it's a green crystalline solid, it's ionic. Okay, that kind of stuff. So that's the kind of way that I would ask that question. Okay, but there are going to be some things about the properties of compounds. So if there's one lesson that you actually read the notes for a little bit, it's probably lesson 4. Okay, unit 1, lesson 4. Okay, that one will have some stuff in it that you'll need to go over. And of course, look over your properties of compounds lab report. Okay. All right. Solubility. Okay, we had that lesson on solubility and the polar nature of water. Because we talked about water's polar nature in like 3 units, okay, that's probably important. So I would look at it in the context of each of the 3 units, because there is a question on the exam about the polar nature of water that actually incorporates all 3 times we talked about it. Okay, solubility, that's going to be mostly like terminology, a couple of multiple choice questions about things like precipitates and, like figuring out which one is the precipitate. You had a question like that in your reactions lab where, in reaction 6, there was a precipitate. What was it? Okay, probably going to see something like that in the multiple choice as well. Here's a reaction. Which, if any, of the products are soluble? A, both. B, none. C, this one. D, that one. All right. Everyone follow there? So something like that. Again, guys, I'm going to ask the same things on the final that I asked on the unit exam. Okay, I'm not coming up with anything new, right? I don't. In my opinion, a final exam is not a place to come up with the most new and novel situation that I can ask you about that would, that's not right in my mind. I need to know whether you still remember the stuff, not whether you can remember the most complex thing I ever asked you. Okay, that's not what it's about. So the stuff you're going to see on the final, you've seen before. Okay, I'm going to ask it in similar ways so that it's familiar to you and you can demonstrate to me that you still know it. All right, so in that way, don't be terrified. Okay, there's not going to be anything unfamiliar. If something is unfamiliar on the final exam, it's because you didn't study hard enough and you missed something. Okay, but everything on there you have seen before. Okay. All right, really, that's the stuff you need to know from chemistry. Okay, when it comes right down to it, that's the stuff that you need to go over in detail. Right now, as part of reactions, do you need to know the 5 types? Yes, because it's impossible to predict reactions if you don't remember the 5 types of reactions that we went over. Okay, that would be synthesis, decomposition, combustion, single and double replacement. All right, so you do need to go over those so that you can practice your prediction. Okay, and remember, there's a couple of special rules for the combustion reactions, right? You balance it alphabetically, and the rule of 2 for when you have an even number of carbon atoms. Okay, that kind of stuff. All right. So make sure you go over maybe the notes a little bit for lesson 12, okay, just because that's where the reaction types are. Is it a good idea to watch some of the podcasts, or at least parts of them? Yeah, okay, it definitely would be, especially like the later ones on lesson 12, because lesson 12, there's like 4 lesson 12 podcasts, right? There's the one where I went over everything the first day and went over all the reaction types, and then the next 3 are me going over examples. Okay, from the worksheets. Those are probably the ones you'd want to watch because you're going to get the most bang for your buck out of those, right? You don't have to watch for very long to see all the things you need to see, which is a whole bunch of them solved for you, right? Plus, in those ones, I usually put them up and then say, hey, try these. And then, so you can pause it, try it, and then watch me solve it. In that way, it's also a good idea to watch any quizzes that we did in class, right? The podcast of any quizzes is also a good idea because you'll see, here's a question, I'll try it, I'll watch Mr. Coder solve it, and then I'll know if I did it right and where I went wrong. Okay, that is a really good way to prepare for your final exam for chemistry and for physics. Okay, is do a couple, watch them get solved. Okay, if you did them right, then you know you're good. Okay, if you didn't get them right, watch where you went wrong. Okay, or ask about that next week. Okay, all right, so the big thing to remember here, reading your notes is the least priority for chemistry. It's like the biggest priority for bio, okay? But it's the least priority for chemistry. Read a couple of things, but mostly practice your skills. You have tons of worksheets to practice your skills with. You've got all the quizzes that you can practice your skills with, and then the advantage of obviously watching those get solved for you, and looking at your assignments and labs. Okay? Those are the big activities I would suggest you do for chemistry. Okay? So we're not going to get very much chemistry review done today, but that's okay because we can review more chemistry stuff tomorrow, do biology on Monday, and do physics on Wednesday. Okay, everybody follow there? Sorry, not on Monday, on Tuesday and Wednesday because your test is on Monday. Yeah, don't want to forget that. Okay, so we still got no time because it's 9:20 and we're supposed to walk over there now. Okay, so that's where we'll leave it for today. Okay, have a look over things this weekend so you know what to ask. Or sorry, tonight, so you know what to ask tomorrow. Losing my mind here. Okay, chemistry section of your final exam. We'll start out with some balancing. So basically it goes just like your unit exam did. Okay, you're first going to be asked to balance in the written response. And there's like 3 or 4. And then you'll be asked to predict and write and balance chemical reaction. And then mole calculations. Okay. All right, so there are 50 multiple choice questions, 50, okay, multiple choice questions. And there are 15 written response questions. 87 marks in the written response. That makes the whole test out of 137 marks. Okay. It is exactly 1.5 times as long as a unit exam, which makes sense because you have exactly 1.5 times as long to write it. Okay. Okay, so for naming, okay, we're going to have, let's say for ionic compounds. Let's try this one. All right, magnesium's a metal, chlorine's a non-metal. What's this stuff called? Magnesium chloride. What do I not do with names? Well, chemical names. Don't capitalize them, right? All right, so that's a basic one. Okay, you might encounter one that involves something like this. What's special about this one? It needs Roman numerals because iron has more than one possible charge. It can be a 2 or it can be a 3. Okay, we need to figure out which one. So we look at our swap and drop. We kind of reverse it a little bit. Okay, the charge on oxygen is always -2. So how many negative charges are in this compound? 6. Every oxygen is -2, and there's 3 oxygens. So there's 6 negative charges in this compound. Since all compounds have a net charge of 0, that means there have to be 6 positive charges on the iron. I have 2 irons, so the charge on each iron has to be +3. All right, so now we know we need a Roman numeral 3 after iron. Iron, Roman numeral 3, oxide. Okay, and sorry, I see people craning their necks. Better. Na2CO3. What's Na? Sodium. Okay, what's CO3? Nope. This stuff is a polyatomic ion called carbonate. Okay, so the name of this compound will be sodium carbonate. Remember, we don't change the endings of polyatomic ions. We just write them as they appear in the chart. Okay, non-metals get their endings changed to "ide," but polyatomic ions keep their endings. Okay, and then the one naming molecular ones is a bit easier. What do I have to add into the names for molecular compounds? Prefixes, right? So what would that stuff be? Dinitrogen trioxide, right? Okay, are you ever going to get polyatomic ions in a molecular compound? No, because they're ions, and they're only going to be in ionic compounds. All right, so if you ever see more than 2 elements, it's an ionic compound. Okay, there are going to be no molecular compounds that contain more than 2 elements. Okay, this has nitrogen and oxygen, that's 2 elements. Okay, if you have more than 2 elements, like we did here, Na2CO3, that's sodium, carbon, and oxygen, that's 3 elements. Okay, you're dealing with an ionic compound, definitely. Okay, everybody follow there. Okay, sorry, exception. No, not an exception. Never mind, I take that back. You guys only deal with the easy ones, so it'll be carbon and hydrogen in a combustion reaction. That's a molecular compound too. But okay. All right. So the other way, I give you a name, and you've got to write the formula for me. So let's try something simple. Lithium nitride. Ionic or molecular? It's ionic. Lithium is a metal. Okay. So if I want to write this formula out, the first thing I want to do is write the symbols for the 2 elements that are involved, lithium and nitrogen. What do I do next? Okay, how do I balance it? Okay, so I got to write the charges down. Lithium is a +1 and nitrogen is a -3. Not to be confused with nitrogen being one of those special elements that comes as a 2 when it's by itself. Okay, don't confuse the number it comes as when it's alone with its charge. Okay, and on your final exam periodic table, it's in color. I have color coded all the special elements. Okay, anything that comes as a 2 is in yellow. Phosphorus that comes as a 4 is in orange, and sulfur is in blue, or the other way around. Okay, but they're color coded so that you'll know which ones are which. Okay. All right. What do I have to do with these charges? Yeah, drop and swap. All right. So the 3 comes down here, and the 1 goes here. We don't write ones. Can I reduce that? 3 and 1 don't reduce. That's as low as it'll go. Li3n is our final formula. Okay, let's try this one. Magnesium oxide. Ionic or molecular? Ionic. Okay, so we write the 2 symbols, magnesium and oxygen. Oxygen's a -2, magnesium is a +2. So now I drop and swap. If I drop and swap and put a 2 and a 2 here, what am I going to have to do? Simplify. Okay, or I could just go, well, -2 and +2 already add up to 0, so I am already good. MgO would be my formula. Okay, let's try. Copper 2 sulfates. Okay, it's got a Roman numeral. It's definitely what kind of compound? Ionic, because you don't put Roman numerals in molecular compounds. What does the 2 tell me about copper? Okay, it does have more, and its charge is +2, right? It does have more than one charge, and this time you're using the 2+ charge, not the 1. All right, and then I got to find sulfate. Okay, this doesn't end in "ide", so it's what kind of a? It's a polyatomic ion, right? So I go up into my chart. Sulfate is SO4, and it is a -2. 2 + 2 and -2 cancel each other. Okay. Then that's my formula. Okay. Let's try this as something different than that, but similar. Whoops. nickel 2 hydroxide. Okay, so we go nickel is Ni, and the Roman numeral tells me it has a 2+ charge. What about hydroxide? Polyatomic ion that's OH with a charge of -1. What do I have to put around the OH here? Brackets, right? NiOH bracket 2. All right, we'll talk more about that tomorrow.